Greetings everyone. Welcome to the third and final video for section 8.6. And in fact, this will be our last learning lesson video for the entire quarter. Can you believe we finally made it? Crazy town, right? But I also know you all are super sad this is the last video, but you know, I could provide you with other ones if you wanted. Okay. So for our last example, what we're going to do is what's called parameterize a line. Going through these 2 points. And basically what that means is that we're going to write a parametric equation for the line passing through those 2 points, or a set of parametric equations. And we know, well, assuming that these are in Cartesian coordinates, which we can because it says right here, we know that these are 2 sets of x and y coordinates, right? In order to parameterize, what we need to do is introduce a third variable that'll be a parameter. And as per normal, we use t as that third variable. So how are we going to do this? Well, I'm going to start by setting up a table. So my x, my y's, and put in the corresponding values here. So we have one point that's 1, 5, another point that's 2, 1. And then we need to choose or figure out the t values that go along with these. Now, what's really nice is that we can actually just sort of choose the t values that go with these points. And as we do that, well, we want to pick ones that are super convenient and maybe the easiest ones to work with. So for example, I'm going to choose 0, t equals 0 to go with the first point, 1, 5, and t equals 1 to go with the second point, the 2, 1. And again, if you think about this kind of paradigm or this way of thinking of parametric equations as a coordinate or a object moving across a map, we could say that at time 1, it was at the point 1, 5. Excuse me, at time 0, it was at the point 1, 5. And time 1, it was at the point 2, 1. Okay. And so then what we need to do are find our 2 sets of equations, right? We need to find what x of t would be, or what x would be as a function of t, and what y would be as a function of t. And since this is a line, you might guess that the equations of each of these, of x and y, should be in linear form, which we normally think of as being that mx plus b form. However, in this case, our input variable is not x. In each case, it's t. So we're really looking for an mt plus b form. And when we write an equation of a line this way, what is the first thing we always need to find? Right, the slope. So let's go ahead and do that for the x of t. Now also, when we find slope, we usually use that standard equation, m equals that y2 minus y1 over x2 minus x1. However, there's a problem. If we're doing x of t, what we're really looking at is just the x coordinates and the t coordinates. And there's no y values to be had there, right? We can't use any y values, and that formula does not include t values. So what might we do instead? Well, recall that another way to think about the slope formula is change in outputs over change in inputs. And in terms of our t's and x's, we know that the input values are the t values and the output values are the x values. So with that in mind, we can actually change our slope formula here to, instead of be y2 minus y1, I'm going to make it x2 minus x1 over t2 minus t1. Because in this case, my x's are the outputs and our t's are the inputs. So if we do that, I'm going to say that these are my x2 and t2 and my x1 and t1. So I plug those in. So I'll do 2 minus 1 on the top for the differences in the x's over 1 minus 0 for the differences in the t's. If we do that, it looks like 2 minus 1 gives us 1 over 1 minus 0 gives us 1. 1 over 1 gives us a 1. So for our x formula, the slope value is 1. And we have to find the value for b, which we know is our vertical intercept. Remember, the value for b can also be or thought of as the value where the input is 0. In this case, we actually know that, right? For an input value of t equals 0, we see that our output value for x is 1. So that actually gives us the value for b. Okay, so we know the value for b is also 1. So then our equation up above, using that mt plus b form, would be 1t, which is just t, plus the value for b, which is 1. So we had x of t equals t plus 1. Okay. All right. Now to work on our y, our formula for y. We again are going to approach it, because it's a linear equation, with this mt plus b form. And we again need to start by finding the slope. And we need to modify our slope formula again to fit our x's, or y's and t's, excuse me. So in this case, our slope formula looked like y2 minus y1, since those are our outputs. We think about t's and y's. Over, again, we'll be doing t2 minus t1, since those are our input variables. And again, over here in our table now, we're just looking at these values and these values. And I'll choose the 1 and 1 to be my y2 and t2, the 5 and 0 to be my y2 and y1. So this will give us, let's see, 1 minus 5 over 1 minus 0, which will give us negative 4 over 1, which is negative 4. And that'll be our slope for our y equation. And then again, we can use the value where t equals 0, which is the 5 for our value for b. And so plugging that into our mt plus b, we see that the equation for y of t would be negative 4t plus the value for b, which is 5. All right. And so there we go. So our equations would look like x of t equals t plus 1, y of t equals negative 4t plus 5. Okay. All right, that's it for now. Thank you guys for watching.